So you're staring down a machining challenge, right? Maybe some really massive heavy parts. And that trusty vertical machining center, the VMC, well, it probably comes to mind first. But you're maybe wondering, for this level of serious metal removal, high volume production, is there a genuinely better way?
That's a great question, and it's exactly what we're tackling today. We're doing a deep dive into horizontal machining centers, HMCs. Our mission, really, is to figure out why these horizontal machines often outperform the vertical ones when the demands get really high. We'll be digging into the key ideas from our source material to shed light on those core advantages.
Okay, yeah, let's unpack that. The source material seems pretty clear that HMCs are generally, well, better for this heavy-duty work. It mentions things like robust structure and rigid construction with a shorter structural loop. What does that actually mean in the real world?
Right. It's fascinating, actually, how that basic design difference impacts things, that rigidity, that shorter loop.
Yeah.
It's all about minimizing vibration and deflection, which is critical when you're cutting a lot of metal.
Vibration, yeah. You really don't want that.
Exactly. Think of it like trying to hold a long, thin stick steady versus a short, thick one. The HMC structure is just inherently more stable,
Mm.
and that lets you take heavier cuts faster without losing accuracy. It really boosts your throughput.
Okay, got it. Stability is key for accuracy with heavier cuts. The source also talks about the horizontal spindle and the larger bearing capacity because the work table is horizontal. How does that help with those really weighty parts?
Well, think about distributing weight. That horizontal table spreads the load much more effectively.
I don't.
Imagine placing a huge, heavy book flat on a table versus trying to balance it on its thin edge.
Much more stable lying flat.
Precisely. And the larger bearing capacity just means the machine's built from the ground up to handle that massive weight reliably. You know, on a VMC, the height of the column can sometimes limit how big or heavy a part you can handle. That's generally less of an issue with an HMC design.
That makes a lot of sense. Okay, another big point the source brings up is superior chip evacuation. When you're hogging out material, you get tons of chips. Why is the horizontal setup better at dealing with them?
Ah, chips. Yeah, managing them is crucial for efficiency and the quality of your final part. With a horizontal spindle, gravity is basically your friend.
Right.
The chips just fall down, away from the tool, away from the workpiece. The source calls it gravity's helping hand, which is a good way to put it.
Yeah.
Especially helpful if you're machining deep pockets or cavities where chips could get trapped.
I can picture that, just falling straight down and out of the way.
Exactly. And that simple difference means less tool wear, which saves you money, and it stops chips from being cut again, which is a big reason for poor surface finishes.
Okay, so what's the problem for a VMC then? What's that uphill battle the source mentions?
Well, with a vertical spindle, gravity works against you, doesn't it? Chips tend to fall right back onto the part, especially in holes or pockets.
Yeah, I can see that.
So you often need, like, high-pressure coolant or air blasts to try and clear them. But even then, you've got a much higher chance of recutting those chips. That can damage the tool, damage the part finish.
So it's not just messy, it actually impacts the outcome. The source links this better chip evacuation on HMCs to less heat, longer tool life, more consistent finishes. That sounds like a pretty significant set of benefits.
Well, absolutely, it's huge. Better chip flow means cooler cutting, so tools last longer. And a cleaner cutting zone means a smoother finish. You might even need less finishing work afterwards.
Right, potentially cutting out whole steps. Okay, so
Yeah.
we've got the structure, the chip management. Let's get practical. When should you really choose an HMC over a VMC? What kinds of parts or jobs make it the clear winner?
Okay, yeah, HMCs really come into their own when you're dealing with larger, heavier parts, and often more complex ones, too. Think engine blocks for cars,
Mm.
big aerospace components, things like gearbox housings, anything with that kind of boxy, prismatic shape.
Like engine blocks, aircraft casings.
Yeah, those sound like prime candidates. Definitely. And they handle all sorts of materials: steel, cast iron, copper, aluminum. The stability we talked about is just perfect for that kind of heavy work.
And what about parts that need work on multiple sides? That seems like it could get complicated fast.
That's another area where HMCs really excel, especially ones with a built-in rotary table. You can machine multiple faces, say 4 sides, maybe even 5 if you use an angle head, all in one setup.
Ah, and the source mentioned tombstones. What's that about?
Right, tombstones. Picture like a vertical block, often with 4 usable sides, that you mount onto the HMC's rotary table. You can then fix multiple parts or multiple faces of one big part onto that tombstone. The machine just rotates the tombstone to present the next face or the next part to the spindle. No need to stop and reclamp constantly.
Okay, I get it. Tombstones let you load up a bunch of work, so instead of flip, clamp machine on a VMC,
Exactly.
you just load it once on the HMC tombstone and let it run through multiple sides or parts. That sounds like a huge time saver, especially for production runs.
It is. And think about accuracy, too. Every time you reclamp a part, there's a tiny chance of introducing error.
True.
By doing multiple faces in one clamping on an HMC, you minimize that risk. Better accuracy, less potential scrap. It's a win-win for complex parts.
So moving to an HMC isn't just faster for complex parts, it can actually be more accurate too.
Precisely. And that ties into another advantage: high volume production. Many HMCs have features like pallet changers.
Pallet changers.
Yeah, so you have two pallets. While the machine is cutting parts on pallet A inside, you can be outside loading fresh parts onto pallet B. When pallet A is done, the machine swaps them automatically. Pallet B goes in, pallet A comes out for unloading and reloading.
So the spindle is cutting almost continuously, minimal downtime for loading.
Exactly. Combine that with tombstones holding multiple parts, and you can see how spindle uptime goes way up compared to a typical VMC setup in high production. And again, that underlying rigidity lets you run higher material removal rates needed for volume manufacturing.
Okay, so summing that up, HMCs seem ideal for the big, the heavy, the multi-sided parts, and definitely when you need high volumes. Let's talk work holding, though. Setting up those tombstones sounds maybe more complex than just slapping a vise on a VMC table.
That's a fair point. It can be more involved initially. HMCs often use those tombstones on rotary tables. And the source mentions lattice screw holes. That's just a grid of threaded holes on the tombstone, giving you lots of flexibility to position and clamp different parts or fixtures precisely.
Okay.
So yes, the first time you set a particular job, it might take a bit more planning, maybe some careful measurement to get everything perfectly aligned. But the payoff is huge in reduced setup time per part later on, especially for those complex jobs or long runs.
Right. Invest time up front for faster throughput later. How does that compare to the VMC approach?
Well, the source calls VMC work holding more direct and simpler. Usually it's a T-slot table, you bolt down vices, maybe some custom fixtures. It's straightforward.
Easier to see what you're doing too, I imagine.
Yeah, visibility is generally better on a VMC, which can make setup and troubleshooting a bit easier, especially for simpler one-off parts.
So it's that trade-off again. VMC setup is quicker for simple single parts. HMC setup takes more effort initially, but wins big on complex parts or volume production by handling multiple faces or parts at once.
Exactly. And the source also noted some HMCs have that built-in rotary function, which is great for things like crankshafts or wheel hubs, circular parts.
Gotcha.
Definitely.
Okay, let's circle back to that multi-sided machining capability. The source really hammers this point home. Why is it such a big deal compared to trying to do the same on a VMC?
Well, think about the inefficiency and the potential for error. Imagine a part needing work on, say, 4 or 5 sides. On a VMC, that's 4 or 5 separate times. You have to unclamp it, flip it, maybe rotate it, indicate it in, reclamp it.
Ugh, yeah. Lots of handling, lots of opportunities to mess up the positioning slightly.
Exactly. All that handling takes time, operator time, machine downtime. And each time you reclamp, you introduce a chance for small errors to creep in. Those errors can add up, especially in height tolerance parts.
I can definitely see that impacting the final quality.
Right. Now, the HMC, with its integrated rotary table, that's usually called the B-axis, changes the game. It can rotate the part itself or the tombstone holding the parts. So you clamp it once, and the machine accesses multiple sides. The source gave an example. A 6-sided part might take 7 or more moves on a VMC.
7 moves?
Yeah. Whereas the HMC handles most or all of that with way less handling. Huge time savings, much better accuracy because you minimize those reclamping errors. It's invaluable for complex parts, especially in volume, and makes managing all your work offsets way more efficient too.
It really sounds like a fundamental shift in how you'd approach machining complex shapes. Not just faster, but potentially much more precise, because you're doing multiple faces on the same workbench, like the source said.
That's it, exactly.
Yeah.
And sure, you can put an add-on rotary table on a VMC, but the HMC's integrated B-axis is typically built tougher, designed for constant indexing and even contouring. It's just more robust for that kind of multi-sided work.
Okay. One last thing, the source mentioned future trends briefly. What's coming down the pike for HMCs?
Well, the usual suspects in machine tool evolution, really. Higher spindle speeds are always a goal for faster cutting. Also more sophisticated controls, adaptive control systems that monitor the cut in real time and adjust parameters automatically for, better efficiency in tool life.
Harder machines.
Smarter machines, exactly. And of course, more automation. Faster automatic tool changers, integrated robotic loading and unloading,
Mm.
anything to maximize output and keep the machines running.
Makes sense. So, to kind of wrap this all up, if your shop is regularly dealing with those big, heavy, complex, multi-sided parts, especially in higher volumes, it really feels like the basic design of a horizontal machining center gives you some serious advantages. Stability, chip handling, multi-axis work, things a VMC might struggle with in those situations.
That's the core takeaway, yes.
Mm.
For those really demanding jobs, the HMC's package, the rigidity, the chip evacuation, the built-in multi-axis capability usually leads to higher precision parts, greater overall productivity, and just better efficiency compared to most VMCs.
This has been really insightful. It definitely makes you think. Considering the complexity and scale of your own machining needs, how might switching to or incorporating horizontal machining fundamentally change your production approach? It's certainly a key question as parts seem to get bigger and more intricate all the time. Thanks for digging into this with us.